All right, we are going to talk about the unit circle. So I'm doing this pre-calculus series with Matthew C, and I don't think that they talk about the unit circle, or if they do, it's not where we're currently at. We are in between lesson 8 and 9 right now, and it just seems to me like it'd be a good idea to talk about the unit circle, partially because of what's coming up in unit 9. Or lesson 9, one of the ways I know how to talk about it refers to the unit circle. So if we don't have any idea what the unit circle is, that's not super duper helpful. If you'd like a copy of this unit circle that's blank to use to practice, I've got a link for just a blank copy of the practice for my website. If you're a teacher and you'd like to have a copy of this to use as a quiz, as practice, and the solutions as well, you can head to the link in the description for my Teachers Pay Teachers, where you can get this for free there as well. But this is the unit circle that we're going to talk about. The unit circle is something that allows us to use these special right triangles that we know and love, right? 30, 60, 90, 45, 45, 90, to use these triangles, which can help us find exact values for trig functions, but to kind of expand that idea and make it really easy to memorize some values or to come up with some values. So what the unit circle is going to help us do is answer questions like sine of 120 degrees or cosine of 270 degrees. That's what the unit circle is going to help us do. Now I'm going to show you how we get the unit circle. What the unit circle is a circle with a radius of 1 unit. Okay, so we want to basically, I'll go ahead and show it. This is what a unit circle might look like. We want to basically take our special right triangles and put it on a circle like this so that we can basically just look at values around the outside to help us know what those questions are, like sine of 120, cosine of 270, whatever it might be. But in order for us to do that, we actually need to address an issue with our special right triangles as we know them. So our special right triangles are 30, 60, and 90, which has a side 1 square root of 3 and 2, and then 45, 90, and has sides 1, 1, square root of 2. If you kind of compare what we've got here, and if I don't know how straight I can draw this line, but basically here's what we're going to do is we're going to make triangles that look like this, that go with our special angles. That was bad. Okay, so if you can kind of combine those and imagine what's happening here, what that means is that we need to change these triangles a little bit because our unit circle has a radius of 1, and these two triangles, their hypotenuses are not 1, and we need them to be. So let's start with the easier situation, which is our 30, 60, 90 triangle here. Our hypotenuse is currently 2. How can we use division to get 2 to turn into a 1? What do I divide this by so that I'll get 1? The answer to that would be 2. So I'm going to do that to everything here. And these other two sides, they don't actually divide. We're going to write them as fractions. What this means is that we can take this and put it on our circle. I'm going to go ahead and get rid of this one for now. So this is our 30, 60, 90. And so this side is 1, this hypotenuse. That makes this side square root of 3 over 2. And this side 1/2. And here's what is really nice about that. If we're saying the hypotenuse is 1, then these other two sides are square root of 3 over 2 and 1/2. What that means, because our hypotenuse is 1, and normally we put sine and cosine over our hypotenuse, is that these two values are actually telling us what sine and cosine of 30 degrees are. And so what we actually do is we'll write this as a point out here. This point right here is literally right square root of 3 over 2 up 1/2. So it's the point square root of 3 over 2 comma 1/2. Now that's not pleasant if you were graphing that on like an algebra style graph, right? But as far as trig functions go, at this point we've gotten lots of things with square roots and fractions in it. So hopefully it's not too bad at this point for you. But what we can do now is we can say, okay, one of these is giving us our cosine value at 30, one is giving us our sine value at 30. Which one is which has to do with which of these sides, this one or this one, is going to be considered adjacent and which one is considered opposite. This bottom part here is adjacent to 30. If we did adjacent over hypotenuse, we'd have square root of 3 over 2 over 1, which is just square root of 3 over 2. So this point is cosine of 30, which is equal to square root of 3 over 2. We can do the same thing with our y value. That 1/2 is representing the opposite side over the hypotenuse, which is sine of 30. What we do with the unit circle is we expand this all the way around the circle so that for any of these points that we end up labeling around the circle, it's giving us our cosine value, comma, our sine value. And so that means that we can hopefully really quickly come up with things like what is cosine of this, what is sine of this. And even for tangent, which isn't listed here, because we know that tangent is equal to sine over cosine, we can realize, okay, well, we'd get tangent by doing the y value over the x value. So in this case, that'd be 1/2 over square root of 3 over 2. That doesn't look fun, but anytime you have two fractions like this and the denominators are the same, you can cancel those denominators out and get 1 over square root of 3, which then we would rationalize and get square root of 3 over 3. I think one of the things I don't actually like about the unit circle is it makes it really easy to get cosine and sine, assuming that you have it memorized or get to use it or whatever. But tangent is not as easy because you actually have to do the work to get tangent. It feels like more work to get tangent from the unit circle than it did just from our special right triangle. So that's kind of my bone to pick with the unit circle. But otherwise, it's really, really great. And part of what's great about it is just that it's a way for us to like combine all of our information into one place so that we can, go, okay, I can look through and I can see where the different angles are. I can look through and see, in which quadrant are things positive and which are they negative and all of this stuff. But first we need a unit circle to do that. So we're going to basically use the 30 here and the square root of 3 over 2 comma 1/2. We can kind of replicate that over here because this is a 30-degree reference angle, and over here because that's another 30-degree reference angle, and over here. I'm not going to write it out here because I have another slide that I'm going to write things out on, I guess. So that would do all of our 30-degree angles. And then just by kind of rearranging this triangle, we'd have our 60-degree angles from up here. That's beautiful, right? So we could basically say this is 1/2 comma square root of 3 over 2 because our 60 degrees down there, we'll just switch the two sides, switch their places. For 45, 45, 90, here's what's going to happen. We have square root of 2 for our hypotenuse, but we want 1, so we need to divide by square root of 2, because that's going to give us 1, but that means we have to divide these other ones by square root of 2 as well, which gives us 1 over the square root of 2, which we rationalize to be square root of 2 over 2. And if you have done sine and cosine of things like 30, 60, and 45 before now, by the way, you should have been getting a lot of square root of 2's, square root of 3 over, you should have been getting a lot of square root of 2 over 2, square root of 3 over 2, and 1/2. Those should have been a common theme. So now we can take this and we can put it on our unit circle here at 45 and say that this is square root of 2 over 2, comma square root of 2 over 2. And really those could have been anything. It just would have changed what our hypotenuse, what our radius was, right? So we could have made both of those be 1 and had a radius of square root of 2, but that would complicate things for our other points. It would make it harder to kind of understand. So I'm going to go to the next slide and basically work on kind of going around filling in the values for the angles in degrees and then filling in the points. There is another space on here. The orange boxes here are actually for radian measure, which we have not talked about yet in this class, but we will later on. So let's just get right to it. Let's start with our angles. Remember that 0 degrees is over on the right side, right here. And then what's happening is these bigger gaps are going to be 30 each. These two smaller gaps are 15 each, because together this makes 45. And then this bigger gap is 30 again, and that pattern continues all the way around. You also maybe could start off by doing what I call the quadrant angle. So the y-axis up here is 90, over here on the left side is 180, down here is 270. We could also label 0 as 360 if we wanted to, and now we can go through and label our other angles. So this is 30, 45, 60. In our next quadrant, we need to add 30 to 90 to get 120. And then this is our angle halfway between 90 and 180, which is 135. This is 150. This is 30 more than 180, so 210. This is 15 more, so 225. 15 more, so 240. And then 300, 315, and 330. If you're thinking, wow, you did that math really fast, I actually do have this essentially memorized. Like, I kind of have to think about it a little bit. I do more of a on-the-fly calculation to get it than I've had this memorized for 15 years or whatever kind of thing. I didn't know about the unit circle as a tool to use for this until I actually started teaching myself. So as I did problems like this in high school and in college for my undergraduate degree, I just made the special right triangle that I needed, and it worked for me. And it may be that it works for you, and that's fine. But it is kind of neat, I think, to see this all kind of put together. So let's go through and label these points. First, our kind of, I guess I could call them our special angles here on the left or right, up and down, which these are the values that are hard to get with special right triangles because they don't make a triangle. But if instead we're thinking, oh, this is a circle with a radius of 1, then this point right here, literally we've gone right 1. I mean, it looks like a really big 1, right, to go from here to here. But that's what the unit circle is. It's a radius of 1. So we've gone over 1, and we haven't gone up or down. So this point would be 1, 0. And we're going to apply that all the way around. So this top one would be not left or right, but just up 1. This one over on the left would be left 1. But not up or down. Down at the bottom would be not left or right, just down. If we kind of go back and forth to our special right triangles and bring our values over, this one was square root of 3 over 2, comma 1/2. These are both square root of 2 over 2. And this one was 1/2 and then square root of 3 over 2. Then what happens in these other quadrants is that we have the same things happening, like because this angle is a 30-degree angle and this angle has a reference angle of 30, this point and this point are going to share values, but this one over in quadrant 2 has a negative x value. So this will be negative square root of 3 over 2 and 1/2. Down here, where we have our reference angle of 30, which would be this point, we're going to have the same square root of 3 over 2, comma 1/2, but now they're both negative because we had to go down and left. And then our last 30-degree reference angle over here would be positive square root of 3 over 2, negative 1/2, because we went right and down. And we can go through and fill in the same information, but for our other two types of reference angles. So the square root of 2 over 2 situation is pretty easy. We just got to pay attention to our negatives. It's really important if you're gonna make one of these and then use it to help you on your homework or use it to help you memorize, it's really important that you make sure you have all of them right. Because I can't tell you how many times I've had a student go, I can't believe I didn't get 100 on this, unit circle quiz. And then they looked at their unit circle, or we looked at their unit circle, and they didn't have it all right. So that would be frustrating. This would be -1/2 and positive square root of 3/2. This will be negative, negative, and this will be positive, negative. Okay, so that's a little introduction to the unit circle for you, and we'll expand on that soon. Thanks for watching. Subscribe.